Hey there, students. On this clip, we're going to be going over, actually, it's like a review on finding amplitude and period of trig functions. So let's go ahead and take a look at the first example. Take a look at number one on your worksheet. We're going to attempt to find the period and the amplitude of this given function. So how do you find that? Remember the steps for finding the period, right? To find the period, what you do is either you go from maximum to maximum. You can go from minimum to minimum. If you want to start from the center, you can go from the center going up to center going down. Center going up to center going up, or center going down to center going down. These are the best ways for finding the period. Okay, I can find 2 points with exactly the same orientation on the graph, and then the distance between those will tell you the period of the function. Okay, so remember, period is side to side. Okay, and then if you want to find the amplitude that goes up and down is basically either you go from center to max, or that's going up, or you go from center to min, that's going down. Okay? Alright, so let's take a look at this graph. Where's our max, min, center? Where the peaks are, these are the peaks right here. Peak, peak, peak. The line containing all these points is known as your maximum, okay? So these are, the peaks are collinear on on a line called the maximum, right? And then the center, or let's say the mean is where the values are, right? The line containing all the points of all the values or the low points of the graph, that's the minimum, okay? So basically right here, this is your minimum. Okay, so you have a max, the peaks, and the values are mean. The center between the max and the min is your center, okay? If you can't figure it out, you just count 1, 2, 3, 4, 5, 6, divide 6 by 2, back up 1, 2, 3, that's your center, okay? So here goes your center. Now, let's look for our period. So period going side to side. Let's look at the nicest point that we can find. We have 0 here. So on this wave, the direction is to the right. So if you have an ant walking up and down this wave, when they get to this point, what direction are they going? Are they going up or down? They are going to be going up. Okay? So this is center going up. When they get here, they're going to be going facing down. Center going down. Or you can look at it as a car. Center going up, center going down. Now, is this a complete period? Absolutely not, because you're facing downwards here. You need to be facing the same direction as where you started from. So center going up, center going down, incomplete. When you get to this point, you have a center going up. So the distance from this point, center going up, to the next center going up is a complete period, because you've completed a cycle, and the same cycle will continue after that. Okay? If you wanted to be fancy, you can go center going down, going back this way. This is center going down also. So from this red to this red is a period, or from this blue to this blue is a period. So the distance from here to here is your period. If you wanted to use the center going up to center going up. So how many units is it from here to here? Look at your x-axis for your calibration. Every tick mark is a pi, right? So if we do 4 of them, 1, 2, 3, 4, 4 pi, our period in this problem is 4 pi. Okay? So let's write that down. Period is 4 pi. Alright, now amplitude. Amplitude, you can either find the distance from the center to the max or the center to the mean, okay? So if I went from center to the max from here to here, how many units is it from here to here? Or how many units is it from here to there? That will tell me what the maximum, what the amplitude is, okay? So if I go from here to here, every tick mark is a 1. So if I go 1, 2, 3, that's 3 units, so my amplitude is 3. But if I wanted to go center to min, 1, 2, 3, that's your amplitude. So there goes your period, and there goes your amplitude. Alright, let's try another example. Let's take a look at this one. So we've got to find the amplitude and period of this number right here. So I first of all need to find my max and my min. So the line containing all the peaks is my maximum. The line containing all the valleys or low points is my min. And the midpoint between the max and my min is my center. So there goes your max, there goes your min, and there goes your center. Oh snap, what am I doing? There goes your max, there goes your min, and there goes your center. Alright, now let's do it. So period. To get a period, remember the 4 steps. So in this case, I'm going from center, here, right here. Since we're going in this direction, my axis is going to be facing up and moving up. So center going up. This is center going down, no, all the way to center going up. So this entire distance right here is my period. Or let's check this out. I can also go from max here. This is max. The next maximum, this distance right here is my period, okay? So if I go from pi to 5 pi, my answer is going to be 4 pi. So the period here is 4 pi. Alright? The amplitude is the distance from the center to the max. So how many units from the center to the max? You go 1, 2, that's 2 pi. And there you have it. Alright, so you can flip your sheets over. This is an example, this is another example set that we're going to be looking at. So in these ones, these problems, these 7 problems we're going to do, we're going to use the sine and cosine curves to find the exact value of the following. So this is y equals sine x. This is the sine curve, and this is y equals cosine x. This is the cosine curve, okay? Now, let's look for y equals, well, let's look for sine 2 pi. So to do this, all you do is you're just simply going to go from x to the graph to the y. And whatever your y value is, that's your output, right? And then whatever your x value is, that's what you're inputting into the graph to generate an output. Alright, so let's start from number 1. Number 1, the x value. This is the x value. Whatever is in the parentheses is your input. So the x value is 2 pi. So we're going to go 2 pi. We're going to go up, down, or stay. Since we're already on the graph, we are going to stay right there, since we're already on the graph, and then just trace our path to the y-axis. If we trace it to the y-axis, our output is going to be 0. So the answer for this one, sine of 2 pi, is simply 0. Okay? You can verify this in your calculator. Make sure the mode is in radians. Okay? So let me set the mode to radians. Start in radians. So I'm going to do sine of 2 pi. And your answer is 0. Alright? Alright, let's try cosine of negative pi. Now, this is our sine curve. This is our cosine curve. So the one we're going to use for this problem is the lower function, this lower graph right here. So starting from the x, we're going to go to the graph and then to the y. So look for negative pi on the x. There you have it. Should we go up or down or stay? Since the graph is below, we're going to simply trace our path down. Starting from negative pi, we're going to trace our path down to the graph and then the graph to the y. So our answer is going to be negative 1. Okay, so there goes your output. So your in is pi, your out is negative 1. Alright, let's try the next one. Sine of negative pi over 2. So sine of negative pi over 2, this up. This is negative 1. Sine of negative pi over 2, we'll start from negative pi over 2, we're going to use the upper curve, that's just a sine. From there, we're going to trace down to the graph, because the graph is down here, and then out to the y. Answer is going to be negative 1. Alright, now let's move on to number 3, cosine of 3 pi, negative 3 pi over 2. So for that one, we're going to use the bottom graph since this is the cosine. This is negative 3 pi over 2 right here. Since we're already on the graph, we don't need to go up or down. We just simply trace our path straight to the y-axis, and our output is going to be 0. So cosine of negative 3 pi over 2 equals 0. Alright, sine of 100 pi. Clearly there is no 100 here, but this graph is periodic when we look at odd or even nature of the inputs. So since we have 100 pi, remember, if the number is, if the input is even, it's coterminal with 2 pi. If it's odd, it's coterminal with with pi. Okay, if it's a negative even number, it's coterminal with negative 2 pi. And if it's a negative odd number, it's coterminal with negative pi. Okay? So there goes your possible outputs. Alright, so now let's take a look at 100. Is this odd or even? Since it's even, this is the same thing as sine of 2 pi. What is sine of 2 pi? We already did this before, right? Just right here, since you're already on the graph, you just trace it to the y, and the answer is 0. So sine of 100 pi, which is equal to sine of 2 pi, is simply 0. How about cosine negative 101? 101 is odd, right? So this is going to be reduced to cosine of what? Negative pi, because a negative odd can be reduced into negative pi, okay? So what is cosine of negative pi? You just go, take this out of there. You just go cosine, this is cosine graph. Negative pi is right here. So you trace your path down to the graph, and then from the graph you trace out to the y, and your answer is negative 1. Alright? Now, how about sine of 105 over 2? For this one, we're just simply going to divide it, right? 105 over 2 as a mixed number. So 105 divided by 2 is basically 52. No, I'm sorry, 50, yes, it's 52. 2 goes here, 5, and 2 goes on the 5, 2 times negative 1. So it's 52 and a half pi. Okay? So 52 is even, right? So it's basically going to be 2 and a half pi. That's what we're going to be working on. So what is sine of 2 and a half pi? That's what we're going to be doing. Sine of 2 and a half pi. Alright? So we're going to go up to the sine graph. This is the sine graph right here. We have 2 pi. So if this is 2 pi, 2 and a half, since everything like is a half, 2 and a half is simply going to be the next mark, right? The next mark is going to be 2 and a half. So if I extend this graph up a little bit to the next mark, where do you think it's going to end up? It's going to end up on 1, because the next half is 1. So 2 and a half is right next to 2, so you can extend your graph there. And guess what? Your output, you're going to go from here, 2 and a half, you're going to go up to your graph, which is the extension you made, and then from that new extension you made, you just trace it to your y, and your output is going to be 1. Okay? So the output here is simply 1. Alright? And now let's go ahead and try number 7. Cosine of negative 17 pi over 2. So this one we're going to divide again like we did before. If I divide 17 over 2, I'm going to end up with negative 8 and a half pi. Okay? Now is 8 odd or even? 8 is even, right? So since it's even, it's going to be reduced to cosine negative 2 and a half, negative 2 and a half pi. Alright, so where is negative 2 and a half pi on the graph? It stops at negative 2 pi. Where do you think negative 2 and a half pi is? It's going to be the next mark, right? So all I'll do for the cosine is extend it down to here, and guess what? That value that we just created is negative 2 and a half. Okay? That's negative 2 and a half. So since that's negative 2 and a half, that's going to be our new inputs because it's the next mark after negative 2. So negative 2 and a half pi. Let me write it again so you guys can see. So this tick mark right here is negative 2 and a half pi. Okay? So this is the input. If this is the input, what is our output going to be? So we're going to go from x to the graph to the y. But guess what? We are already on the graph, right? The graph and the x-intercept, so we don't go up or down, we stay. And just trace our path to the y-axis. And what is our output going to be here? Our output is simply 0. Okay? So for this one, it's going to be 0. Okay? Alright. Alright, we can verify our answers of this one with a calculator. So we can use this value right here because the graph, um, this calculator cannot handle bigger values. Okay, so we're gonna try cosine of negative 2.55. 2.5 is the same thing as 2.5, so negative 2.5 pi. Cosine of that is 0, as you can see our answer indicates. Okay, so thanks for paying attention to this presentation. Remember, it's uploaded on YouTube for your viewing pleasure. Now we're going to go ahead and start with the classwork for today.